Hello statistics student, this video is for chapter 9.5 part 2. We're doing a full hypothesis test for population mean using one sample, and in this particular case our sample is actually a list of raw data, not X-bar, not summarized. So we'll look at how we can find p-value with raw data when we're testing mean. So followings are the measured radiation correspond to a sample of 11 most popular brand of cell phones. So for the most popular top 11, we measure their radiation, and then we want to test the claim that the cell phone have a mean radiation level greater than 0.7. So it's very clear. So your claim, this is a claim, is the mean mu of radiation level greater than 0.07. So we can write the claim right away. The first step is always write the claim. And then we have write down X0, the null hypothesis. So if we think that the claim is greater, then the opposite would be less than or equal. And we use the most extreme one, which is equal to 0.7. The null hypothesis is always equal. And as such, the claim would become the alternative hypothesis. So you record all of them and you actually tell yourself that, okay, this is the claim. And if I do this test at the end, I can support my claim if everything works out, right? And because we have data, we'll input the data to a column. Do we know sigma? Sigma is not given, right? So we probably would have to depend on t distribution. So this is the second step. The second step is always about significant level. They actually are given here is 0.05. That is counted as unlikely. And it is a right tail test because the alternative hypothesis is on the high side. And we use this t distribution because sigma is not given. Then we're ready to calculate p-value and test statistics. So we're supposed to enter those data into a column. Now you are not to calculate X-bar and S and all those before you do hypothesis test. You can actually do it right away. So hypothesis test, population one sample. Okay, so we have data. You just say use data. You don't have to go through two steps of calculating the sample statistics. So we are doing a greater, right? Greater than, what is it? We're claiming that it's greater than 0.7. 0.7. Do we have to adjust the significant? Significant is 0.05, so it's okay. And there you go. We don't have to enter any X-bar. So we just say the column containing the sample data is in column 1. And we are ready to evaluate. So make sure that it's greater and evaluate. Right? So if you hide your sample editor, you see the test statistics is 1.87. And our p-value is 0.0456. Wow, this is really marginal to 0.05, right? 0.0456 is actually less than 0.05, just rare enough to reject X0. So because we reject the null hypothesis, so this is it is not sufficient, it's significant. I think it's a typo. Significant, you have a surprise sample. Significant. I think I mean to use significant. This is a significant sample. We can use the wording sufficient evidence. So yeah, it's not a typo. Sufficient evidence statement. And so maybe I'll just say this is fine. All right. I was planning to say it is you use sufficient evidence. And then the claim is in X0, so we use the word support, right? We are supposing to support the claim. And so we have sufficient evidence to support the claim that it is greater than 0.7. So let's see if the flowchart get the same one. Our claim is X0, so it's this one. Oh, we reject X0, so the sample data support the claim. See how it is the same? So our sample said that it is greater than, it is not lower than or equal to. Is this result useful for cell phone in use, that it is greater than 0.7? No, when we are looking at radiation, we're not interested, doing the mean. We actually want to make sure that the maximum of the radiation is, a particular value. So first of all, mean is not particularly useful for safety purpose. The second is this sample is also not a random sample. It's a top 10 cell phone. So it does not represent all of the cell phone in use. It's not a random sample. Okay. So C is also, you have only 11 data. Can we actually do hypothesis test? Is X bar actually normally distributed because the sample size is so small? So we should actually use normal quantile plot to check for normality. So because our data is already, you look at, it's already in column 1. So what we can do is go to data normality assessment and then just do column 1 and assess it. Check if there's any outlier. Check if the shape is really weird. No, it's actually pretty good. Now it seems like it's right scale because we have only 11 data. It's not, you cannot have demand too much. But if you look at the line, the points, they don't deviate from the straight line a lot, right? So you don't see things that are too far away. So you can say that the normal requirement is okay. So requirement for normal distribution, population normal distribution is satisfied. The third example is from, not from calculating, but looking at output. So a Minitab is a very popular software, statistics software. Suppose someone run a Minitab and they have X bar, I don't know what this X bar is, 9.81, S is 5.01, and N is 50. I think it's some kind of measurement. Oh, here it says use the output to test the claim that mean depth of all earthquake is equal to 10 kilometer. See how the mu is equal to 10, right? And Minitab, they actually have, this is x0, I think, and not equal to 10. This is x1. We really don't know. I think if it is x0 and x1, so probably we can say that this is the claim. We don't know whether the claim is, oh, here they say test the claim that it is equal to. So this is the claim. X0 is the claim, right? So some software actually have record X0 as L as HA, which is the alternative. I keep on using H1 because some of the books use H1. So let's do a hypothesis test with all the information that's given. So we write down the claim, which is just copy from here. The alternative is not equal. Test statistic, we can just find it from here. Oh, we have a t here, negative 0.27, which is quite close to 0. P-value is 0.79. It's also a very big p-value. So it's greater than 0.05, our significant level, right? We wanted to test it at significant level of 0.05. So you fail to reject 0. And what is our claim? Our claim is in H0, right? Because we want to test the claim of equal. This is not very common in a research study, but we're doing that here. So we'll say not sufficient evidence because you have a big p-value, and you would have the statement use the reject word because claim is in the null hypothesis. So the final conclusion is there's not sufficient evidence to reject the claim. You cannot reject the claim that the mean depth is 10. So the claim stays true that the mean depth of all earthquake is still 10. Okay, so if you look at your flow chart, X0 is the claim. We fail to reject 0. There's not sufficient evidence to reject. Okay, not sufficient evidence to reject the claim. It's the same thing. Oh, I don't have to switch. So this is how you do the thing. The next video is about 9.2, going back to analyzing type 1 and type 2 error and discuss a little bit more about significant level. All along, when you do your homework question, they usually give you alpha, which is a significant level, and a lot of time alpha is 0.05. So in the last section, we're going to talk about if I am to do a statistical research myself, should I choose 0.05? Should I choose a higher one or lower one? And it's tied into errors in hypothesis testing called type 1 and type 2 error. So this would be the next video.